Here's our last example in 11.3, and what we have is a 3 by 3, and it gets pretty lengthy when it's a 3 by 3 because you have to go and get actually 4 determinants out, and the 3 by 3 determinants take a while, but it is a good way if you had a lot of variables to handle the organizational piece of it. And so it's a little bit lengthy of a process, but we are going to ask you to do it. And so here's the original system, and I took the time to just go ahead and write the determinant that would be formed to find D. And so there it is. And so those should just be copies of the x, y, and z coefficients from each of the first three equations. And so the way we find determinants, you had a glimpse of that in 9.7. We are going to take 1 and multiply it by the determinant that is outside of its row and column. And so we're going to look at this group of numbers to take the determinant to start out with 1. And so we're going to have negative 1, 1, 3, 6 in there. Then it's always alternating signs, so it's minus, and now we're going to go grab the 4. But when we do, we're no longer looking at that group of numbers. We're looking at a different group of numbers, right? Oops. Let me get rid of that. We're looking at a different group of numbers. We're looking at these numbers and these numbers, the ones that are outside of 4's column and row. And so that's the 3, 1, 3, 6 area. And then finally, we're going to go get the negative 3. Now it's plus, I'll emphasize that, it's a plus negative 3, and then times its determinant. And its determinant would be the one on the right hand side, the 3, 1, negative 1, 1. And then you're running that determinant, 1 times negative 6 minus 3, minus 4 times 18 minus 3, and plus a negative 3 times 3 plus 1 coming out of that. And so what do we get out of this? We get a negative 9 minus, here we're going to get 18 minus 3 is 15. Negative 4 times 15 is 60. And then negative 3 times 4 is negative 12. And so we're not going to be 0. We're getting, and let me not write it there. Let me write it down here. We're getting negative 81. So we can use Cramer's rule. So the next thing we do is we find dx. Well, there's dx. Dx would be taking the x and replacing it with the constants that are off on the right hand side, the negative 8, the 12, and the 1, and doing the same thing, taking negative 8, and then the determinant there, if we just look, maybe we can see it, it would be negative 6 minus 3. Then it would be a minus and a 4 is in the middle. And there we would be taking 12 times 6 for 72, but subtracting away 3. And then it's going to be a plus a negative 3, so essentially minus 3. And then we're going to have 12 minus a negative 1, or 12 plus 1, just to cut down on time in this video. Hopefully you saw that happening. So this is negative 8 times, well, negative 6 minus 3 is negative 12. And minus 4 times 69, minus 3 times 13. And so we're going to get a 72, and a minus 276, and a minus 39. And putting those all together, we get a minus 243 coming out of that. A negative 243 is what dx is. So there's dx. D is up here at 81. We got to do it for the y. That's why it takes so long, right? And so what are we going to have? We're going to have 1 times 72 minus 3 minus a negative 8 times, and what would we have? 18 minus 3 minus or plus a negative 3. Maybe that's how I write it just to make sure you can see those signs. 3 minus 12. And so what do we have? We have 1 times 69 plus 8 times 15 and then minus 3 times negative 9. And so what do we end up here with? 69 plus 120 plus 27. And so we end up with 216. And that's just dy. Guess what? We have to do it for z as well. And there's z right at the end. And so what do we have here? We replace the 0 with the negative 8, 12, and 1. So remember, we're coming back up here to our regular d, keeping the 1, 3, 1, the 4, negative 1, 1, but replacing that last row with negative 8, 12, and 1. So that's what we have. And so what do we end up with? We end up with 1 times negative 1 minus 12 minus 4 times 3 minus a negative 1 and then plus a negative 8 times 3. Oh, I might have done that 4-1 wrong. So I did do that 4-1 wrong. So that happens sometimes. You'll get that feeling as you go to do others. So as we go to do 4, and maybe I did it right, I just question myself. I'm getting 3, right? The 3 times the 1. 1 times 12 is 12 coming in here. And then when I do the last one, it's 3 minus the negative 1. So I had done that wrong. And so what do we end up with? We end up with 1 times negative 13 for negative 13. Negative 4 times negative 9 for positive 36. And negative 8 times 4 for negative 32. And that puts us at, for a dz, a negative 9. So what do we do to finish? Well, we realize x is dx over d. And if you remember, dx was negative 243 and d was negative 81. You may, if you're writing it down with me, you see that. But if you're not, I can scroll back up and you can see those two numbers. And so what's that equal to when we divide those two things? A 3. Y is equal to dy over d. Well, if you remember, dy was 216, d is negative 81, and that comes in to be a fraction of negative 8/3. And then z is dz over d. And you can see right above that dz was negative 9, negative 81, and so we see that that is 1/9. So what's our solution? Our solution is 3, negative 8/3, and 1/9. Now, I don't know what that would have looked like from a process of elimination, doing it the way we did in 11.1, but with those fractions working out, it might not have been as nice. So just a different method to get through and do. It's very lengthy when you have to get all three variables. One of the reasons why I'm asking you to do every other odd is because I don't want to kill you in that process.